Should know. Let's see. What time is it? Oh, it's 8:03. Yeah, shit.
Wow. Cold hearted.
She is, isn't she? So let's start off with the simple one. And what I mean by simple is, I mean this is probably one of the easiest questions going in the world. Ready?
Okay.
3 square root of x is equal to 2. Now there's 2 ways of tackling this. First way is to get everything away from the radical. So in other words, I would divide both sides by 3. But that causes a fraction on the other side. So I wanted to show you 2 possibilities. Because sometimes you'll want to divide by that 3, and sometimes you just want to leave it where it is. All right, so the goal is to get rid of the square root. What do you think you could do to both sides to get rid of the square root?
Square root goes up.
No, it's already square rooted. So if you square root a square root, you get a 4th root. But if you want to get rid of the square root, you multiply it by itself. So you're going to square it. So whatever you do to one side, I'm going to square the entire side. You have to do to the other side to balance it out. Okay. So let's see here. This becomes 3 squared, which is 9. And the square root of x squared, which is?
X squared.
No. What's the square root of x times the square root of x?
Oh, x to the 4th.
What is the square root of x times square root of x?
8 squared.
What is the square root of x times square root of x? X. Square root of 5 times square root of 5. 5. Square root of 3 times square root of 3. 3. So square root of x times square root of x is just x. And 2 squared is 4. You got to be very careful what you write down. You can't just go guessing. You have to know these things. And then to solve it, you're going to divide both sides by 9, and you get x equals 4 nines. Okay, so that's one possible way of doing it without isolating the square root. That's our goal of this section. Isolate the square root. We could have also have done the problem by, same problem, divided by 3 first. Does that change anything? Not really. It just causes a fraction on the other side. So if we divide it by 3 first, that would have left us the square root of x equals 2/3. All right. How do you get rid of a square root? Square both sides. So we're going to square this side. We're going to square this side. And the square root of x squared is equal to? X. And 2/3 all squared is equal to?
4 nines.
4 nines. Either by saying 2/3 times 2/3 or 2 squared over 3 squared, which I prefer personally. And notice the answers are exactly the same. So it doesn't matter which way you do it. Some people don't like working with fractions, so they'll leave it like this. Some people don't mind working with fractions, so they'll go ahead and get the radical by itself. Now, here's the second thing. You won't see these on the test. Why?
They're too easy.
They're too darn easy. So let's get into the ones you will see. We'll start off with something somewhat easy. Number 4. This is on page 389. Square root of 5x minus 4 is equal to 6. So the whole goal behind this, and I'm going to say this many, many times throughout this little quick lesson, is to isolate the radical. What's it mean to isolate?
Get rid of it.
To get it by itself. You want to isolate a single radical, because when you isolate it and you square it, the radical just goes away. Now, if there's other pieces lying around, adding subtraction-wise, it gets a little messy. But this one's okay because this is 1 square root.
Don't lock the door.
I was told to.
Really? Who told you?
Look, she's raising her hand. All right, so this square root is isolated, so all you have to do is square both sides. And what happens is just what happened over here. When you hit a square and a square root next to each other, remember this is a half power, and a half times 2 is just 1, so kind of, I say it goes poof. I hate saying the word cancel, because cancel is usually inverse and identity. So I'd rather just say poof. It goes poof. And what you're left with here is what's inside, 5x minus 4, is equal to, and then 6 squared is 36. Add 4 across, and you get 5x is equal to, what's that, 40? And therefore x is equal to 8. And if you want, you can check your work, make sure you got the right answer. Plug in 8. 5 times 8 is 40. 40 minus 4 is 36. The square root of 36 is indeed 6. And usually they're quick to check. Some of them are a little ugly, but that's all right. So that's it. Pretty simple. So how about number 6? Gets a little messy with signs. 1 equals 5 minus the square root of 9x minus 2. Let me show you a few no-nos that will get involved. The first step of isolating the radical. First step of isolating the radical.
Square.
No, that is not how you isolate a radical. That's how you get rid of a radical. To isolate a radical, you want to get it by itself. So what's next to it that you don't want?
Negative.
No, well, eventually you get a negative, but really,
5.
the 5. So to move the 5, we're going to subtract 5 from both sides. And I'm showing this step because it took you guys forever to figure that out. And it shouldn't have. This is just a linear type equation. 1 minus 5, of course, is negative 4. 5 minus 5, of course, is
0.
because they're inverses. Don't forget this negative. That still is there. Negative 9, the square root of 9x minus 2. Okay. Here's a problem. You really don't want the square root to be negative. Weird things happen when you try to solve it and it's negative. You might come up with answers that really are not answers, and eventually we're going to run into those. So what can I do to get rid of the negative?
Divide it by a positive or a negative 1.
Divide by negative 1, multiply by negative 1, or just change all the signs. So this becomes 4. Positive 4 is equal to the positive square root of 9x minus 2. Remember, this long bar represents parentheses. That 9x minus 2 is locked into that square root. You can't deal with the pieces. All right, and then what can I do to both sides? Square it. So if I square both sides, square the 4, square the 9x minus 2. 4 squared is 16. And this is going to equal 9x minus 2, because the square and the square root go poof instead of cancel. All right, and then just solve for x. Add 2 to both sides. You get 18 equals 9x. And divide by 9, and you get x equals 2. Once the square root is gone, it's usually pretty quick to get to your answer. Usually. Sometimes not so. Is 2 really an answer? Let's check it. Take 2. 9 times 2.
18.
18 minus 2.
16.
Square root of 16. And 5 minus 4, of course, is 1. So it does work. Will they always work?
No, of course
not
not.
really. Do they have one in here? Oh, they didn't do one. Oh, no, they did. There it is. Number 12. And I have to explain why number 12 doesn't work. And hopefully you see it right away. You're looking at it and go, well, it looks like a normal equation. Looks like just the other ones over there. So what do I do first?
Subtract 12.
Subtract 12 from both sides. So we get the square root of 4x plus 5 is equal to
5. Negative 5.
negative 5. Okay. What do I do to both sides?
Multiply. Square.
Square it. Since we've isolated the square root, which means gets it by itself on one side, we're going to take the entire thing and square it. You square the left, you square the right. Okay. So, let's see. On the left-hand side, we get 4x plus 5. On the right-hand side, we get 25. Okay. Sounds good so far. Subtract 5. We get 4x equals 20. And finally, we get x is equal to 5 by dividing by 4. Woohoo! Answer, right?
No.
No. Watch. Take 5, plug it back in. 4 times 5 is? 20. Plus the 5?
25.
Square root of 25?
5.
12 plus 5 is 7.
No.
No. So what went wrong with this one?
I don't know. You
What
can take
Signs
four.
are negative.
What's that?
If it would have been negative, they would.
If it was a negative 5, it would be perfectly fine, but it's not. So what went wrong?
You can take the 4, you can square the 4, can you?
What? Look at this equation all the way through every step, especially step number 2. What's wrong with line 2?
Because negative 5 is negative.
Ah, because the 5 is negative, and the square root of x always has to be positive. There is no way you're going to get the square root of 4x plus 5 equal to a negative number, because square roots have what's called principal roots that are always positive. At this line, you could have stopped and said no solution and not done any more work. Now be careful. This one is also a negative on the other side with a negative 4. But both of them are negative, therefore you have to do a little extra work. So the goal is isolate the radical and see what happens. So because of this, and because 5 does not work up here, this thing is no solution. Okay, so be careful. Don't just assume it doesn't work. Sometimes you might want to check your answers just to make sure you are getting the right answer. I wouldn't generally worry about it too much if everything's positive to begin with. But once you start throwing negatives around, especially in front of radicals or on the other side, you might want to just check your answers to make sure that it is actually a solution. Kind of like those rational expressions where x can't equal 3 and find the solution as x equals 3. So just another little cautionary area. All right, do they get worse? Unfortunately. Number 20. Not horrible, but square root of 5x squared minus 3x is equal to 2x. The technique is the same pretty much consistently through this. What do I do to both sides? Square. The square root is isolated, so we're going to square both sides. Don't just square pieces. Make sure you square entire sides, especially if there's a sum or a difference there. So the left-hand side becomes
5x squared minus 3x.
5x squared minus 3x. The
4x
left-hand
squared.
side becomes
4x squared.
4x squared. You got to square both pieces. All right. How do I solve this equation? Well, actually, number 1, what kind of equation is this?
Linear.
It is definitely not linear.
What was a guess, man?
Well, it's a bad guess. What's wrong with this that does not make it linear? It's got squares in it, so we call it a
Trinomial.
closer.
Polynomial.
Begins with a Q.
Quadratic.
Quadratic. It's quadratic. So you subtract 4x squared and you get x squared. Oh, by the way, yeah, quadratics you always want to get them equal to
1.
Say it again. 0. You always want to get it equal to 0. So subtract 4x squared, you get x squared minus 3x is equal to 0. Remember quadratics? I think we taught this before.
No, you didn't teach.
Factoring and all that fun stuff. Can I factor that? What can I do?
Take out the x.
Kick out the x. Left behind is x minus 3. So, what do I do with the two factors? You get a quadratic, you factor it, and it's equal to 0. So what do I do with the two factors?
Set them both equal to 0.
Set them both equal to 0. So we get x is equal to 0 for the first factor, and x minus 3 is also possibly equal to 0. This one's obviously solved already. This one over here gives us x equals
3.
3. Now, I have two answers. Do both of them work? Let's find out. Take 0, plug it in over here. What do you get? 0. 0 over here.
0.
Square root of 0 is?
0.
It works. Now 3, that's 9. 9 times 5 is 45. Minus 9. 45 minus 9 is 36.
6.
Square root of 36 is?
6.
6. And 2 times 3 is?
6.
6. So both of them are our answers. And to indicate that, I'm going to say x is equal to 0 and 3. Remember my nice little set notation garbage? The pretty squigglies that nobody likes drawing? Ah, I won't. Wait a minute. Which one? Where the heck is it? No, the one I started erasing. Yeah. I guess I can make my comment. That's what you get for being late.
You just didn't have to say it.
Haven't.
You were late yesterday. Out there talking in the hallway. Yeah.
Oh my lord. So these things can have quadratic possibilities. Oh, they really jump into the horrid stuff. They don't give a lot of examples of the good ones.
About 22.
Well, actually, I was looking at 14. By the way, 20 is easier than 14. All we had to do is square it and it popped right out as a good answer. 14 is actually the harder of the two. So I'm curious why they put it up here rather than, reverse the order. Square root of 2y minus 4 plus 2 is equal to y. Alright, so what do I do?
Check that 2.
Subtract that 2. You want to isolate the radical. So subtract 2 from both sides. And what's left is that square root of 2y minus 4. And it's going to be equal y minus 2. Do you see why this one's trickier than number 20? Yeah?
Mm-hmm.
Why?
Because they want to get like terms on each side and all that.
No, not like terms. When I square both sides, because it is isolated now, what happens to the y minus 2?
You gotta multiply them.
You got to expand it out, and it's definitely not y squared plus 4. It's y squared minus 4y plus 4.
Oh, yeah.
FOIL, first order interlaps. So that's why this one's a little trickier. Over here, the square root goes away, and you get 2y minus 4 is equal to y squared minus 4y plus 4. If you don't see that, go off to the side and do y minus 2 times y minus 2. 2 factors of y minus 2. And FOIL it all out, and that's what you'll get. Okay, now what? What kind of equation is this?
That quadrant.
It's a quadratic equation. My goal is
Set 0.
get it equal to 0. Which pieces do you want to move?
The left to the right.
Move the left to the right. So we're going to subtract 2y and
Why?
add 4.
Oh,
You want to move those two pieces over, so you do their opposites, their inverses. And over here, I'm going to line it up with what it will go with. Subtract 2y and add 4. Okay. So on the left-hand side, we get a big fat 0. Don't forget to write that. It is important. We need that 0 there. This is equal to y squared minus 6y plus 8. All right. Now what?
You can pull out
Pull out.
4y minus, be negative 4y
You ain't got the
minus 2y. You just stay in the
Okay,
square.
you said the right numbers just horribly.
It's y minus 4, y minus 2.
Y minus 4 and y minus 2. Do you see what I said by you said it horribly? Factors of 8 that add up to 6, negative 4, negative 2, so it becomes y minus 4 and y minus 2. So now I take my two factors and set them both equal to 0. So you get y minus 4 is equal to 0 and y minus 2 is equal to 0. You can skip that step, but if you get lost, you want to go back to the back to basics and figure it out by hand. And then we get y is equal to
4 and 2. 1, 2, and 4.
4 and 2. Do they both work? Now this one's a little trickier to answer.
Oh, I thought it was gonna be.
I thought you were late.
What?
We're getting there.
Alright, this one's a little trickier because, for instance, this last one over here, we had a square root equal to a negative, and pretty much we could say, oh, that one's not going to have any solutions. And the only reason that wasn't a solution is because the other side was negative. But y minus 2, you don't know what it is until you plug something in. So if I plug in 4, does that make it negative?
No.
More than likely it's going to work. If I plug in 2, does it make it negative?
No.
No. So more than likely it's going to work, but I'd like to check both of them. So take 4, 2 times 4,
8,
8 minus 4,
4,
square root of 4,
2.
2, and then 4 minus 2, of course, is 2. So 4 works perfectly fine. Well, I already wrote it in squigglies, so I kind of, yeah, you're kidding.
That's the wrong thought.
I know, you can't resist the smile.
It's her fault. It's her fault, yeah.
It is.
And if you take 2 up, you're going to get 2 times 2 is 4, 4 minus 4 is 0, and then on the other side you get 2 minus 2, which is 0, and it works. But you have to be careful. Sometimes one of these answers might not work, and sometimes neither of them work. But usually it's just one. So you got to be careful. You do have to check your answers in these type of problems. That's one thing people hate doing.
I got a question.
Go for it.
Why did you pull out that 0 is equal to right there that y minus 4 and that y minus 2?
When you have a quadratic and it's in factored form, the idea is if this is going to equal 0, one of these factors has to equal 0. You know, it goes back to that, if a times b is equal to 0, then either a is equal to 0 or b is equal to 0. One of them has to be 0, because if they're not, then it will never equal 0. The product of two numbers equal to 0 forces one of them to be 0. At least one of them. Don't you remember that when we did quadratics?
Yeah, but I still can't.
She did.
We did quadratic equations.
That's all last chapter.
Yeah,
She
it was
always
last
said-
chapter. When we factored and we said it, it was actually chapter 5. If I remember right. Maybe you want to look back. Oh, chapter 5. Special cases of factoring. Solving equations and applications using polynomials. Section 5A. Yes, we've done this. I'm just forcing you to use language. What's worse than this? Number 26. Well, before we get to number 26, let's do a simple one. Number 24. 24. The cube root of 3 minus 5x is equal to 2. Now, this type is never going to have a binomial on the other side because to get rid of the cube root, what do you have to do to both sides? Cube them. And that means you would have to cube root a perfect binomial, and that's a mess. So we're going to cube both sides. And that'll get rid of the cube root, because the cube and the cube root being a 1/3 power, they'll cancel each other out. And we'll get 3 minus 5x, that'll go poof, is equal to 8. Subtract the 3 and we get negative 5x is equal to 5. And therefore x is equal to, is that a problem having x equal to negative 1? Would it ever be?
I don't know.
You tell me.
No, because this problem is already negative.
What's that?
It's the x is already going to be
No,
negative.
not because of that. There's another reason overlying even that. Could we care less if a cube root is negative or positive? No, that's the main reason. Because if the index is odd, I could care less what kind of answer we're going to get. So all of the answers will always work. So the answer is x equals negative 1. That's the beauty of cube roots. No matter what you get, the answer has to work. Square roots you have to be careful because everything has to be positive. All right, how about number 26? This is probably the hardest it'll ever get. Unless they have some nastier ones in the next one. Ooh. They have worse ones. 26 is bad enough as it is, though. Square root of x plus 6 plus 1 on the outside is equal to the square root of x plus 15. Probably the better way of writing this problem would be to write it as 1 plus the square root of x plus 6. So you don't get confused about that 1 being on the inside or on the outside. So that's probably a very poor way of writing it. Go for it.
It's 15. What?
I don't know why I wrote 11. No idea. 15.
I don't know how you expect us to learn to keep.
Oh, Jeez. Okay, so the goal stays the same. I need to isolate a radical. The problem here is there's two of them. It doesn't matter which one you isolate. As long as you get one of them by itself, then the other one on the other side. I hope I have enough room for this one. Well, is one of them isolated? Yeah, this one over here is isolated. I could care less about the other side. So since this one is isolated, I'm going to square both sides. And be careful, you're squaring entire sides, not pieces of sides. All right. Do I have to write this one out? Probably. So let me expand it out. This is a binomial. So I have to write it twice. So it's the square root of x plus 6 plus 1 times the square root of x plus 6 plus 1 is equal to, what happens on the other side?
Get rid of the radical.
The radical will go away with the square, and you get x plus 15. Okay. How do I multiply the left-hand side together?
Foil.
Just FOIL it out. Square root of x plus 6 times the square root of x plus 6. It's just plain old x plus x plus 6. Because the square root of 5 times the square root of 5 is 5. Square root of x plus 6 times the square root of x plus 6 is x plus 6. Nothing on the inside is going to change. All right, then you do outer. So we get 1 square root of x plus 6. Notice I left a little space here. And then we're going to do the inner, and that gives me another 1 square root of x plus 6. So that gives me how many of them? 2. So I get 2 square roots of x plus 6. And then 1 times 1, of course, is 1. Okay, now what? You can. Yeah, there is. The 6 and 1 is 7. But what else would you want to do?
Find like terms.
After combining like terms. Move the 15 to the left. Well, you weren't here. What's the goal of solving the square root? Isolating the square root. Where's the square root? Well, it's right here. So I need to get him by itself. So what do I need to move?
X plus 6.
The x, the 6, and the 1. So what I'm going to do is I'm going to subtract x from both sides and 7. 6 plus 1. So I'm going to go over to the other side and subtract x and subtract 7. Okay, what's left? 2 square root of x plus 6 is equal to 8. Now, because the 8 is even, and the square root has a 2 sitting in front of it, I would divide by 2. If the 8 was like a 9, I would probably leave the 2 where it is, and then just square both sides. So when I say isolate a radical, it basically means get rid of all the additions and or subtractions that are next to it. You can leave the 2 there, but if you can get rid of it, it's probably better to. It makes life a little bit easier. So in this case, I'm going to divide both sides by 2. Okay. So that gives me, bring it up here. No. The 2's are the only thing that cancels. What's left?
X plus 6 equals 4.
The square root of.
Oh, square root.
You don't get rid of that yet. Square root of x plus 6 is equal to
6.
4.
Oh, 4.
What are you subtracting 2 for?
I don't know.
Now, well, how do I get rid of the radical? Square both sides. So we've done this squaring twice, just to get this problem solved. Alright, so left-hand side, x plus 6. Right-hand side, 16. Therefore, x is equal to 10. Woohoo! But, here's a difficulty. We squared twice. So it's possible we took a negative number and made it positive twice, and therefore that answer might not actually work. So back to the beginning. 10 plus 6?
16.
Square root of 16?
4.
4 plus 1?
5.
5. 10 plus 15? Square root of 25?
5.
And it works. So this is a perfectly fine answer. But you have to be careful when you're double squaring. You might be forcing negatives to become positives when they really shouldn't be. If the answer doesn't work, you put a little circle with a line through it. Don't I have one up here? Ah, no, you were too late for that one.
Is that
7 what?
7-5. 7-1.
As long as it's doing it.
Let me just do one of the horrible ones in case I throw one on your lap. What's the worst one? Negative, no, negative. Number 36. That's the worst it can be. Oh, well, 38 is probably pretty bad too, but the worst I'll get ever is this one. This one is not fun to solve. Not even to me. Square root of 3x plus 4 plus the square root of x plus 5 is equal to the square root of 7 minus 2x. Okay, what should I do first?
Square everything. Count it up.
Is there a radical that is isolated?
Yes.
Yes, I could care less which one it is, but there definitely is one. It's the 7 minus 2x piece. So now we can just square both entire sides. Woohoo! How fun this is going to be. Do you want me to copy out that binomial twice? I'd rather not, but okay, I will. Do it. So we get the square root of 3x plus 4 plus the square root of x plus 5 times itself. And this will equal 7 minus 2x, because that square and square root will cancel. What's the common mistake here? Well, people think this square is making these two first radicals go away. And obviously it doesn't, because you have to FOIL it out. And some of them will go away, but some of them will kind of stay around. So, if I multiply this out, let's see what happens. First, this one times this one.
Get 2, 3x plus 4.
No, you do not.
And he was on
Square root of
time.
9.
He just-
I know.
You did over
He
there.
didn't have his coffee this morning. Square root of 5 times square root of 5 is
5.
5, not 2, 5. Just 5.
You put
So the square root of 3x plus 4 times the square root of 3x plus 4 is 3x plus 4. You're one step ahead of me. Now if we do outer, we get the square root of 3x plus 4 times the square root of x plus 5. And if we do the inner, we get the exact same thing. That's when we get 2 of them. I'm going to leave it alone like this. Plus 2 square root of 3x plus 4 square root of x plus 5. You can put them under the same square root, but I want to keep them kind of separate. Otherwise it gets a little messy. All right, and then last,
X plus 5.
you're just going to get a positive x plus 5. Because the square root of x plus 5 times the square root of x plus 5 is x plus 5. The other side stays the same for now. 7 minus 2x. Great. Now what should we do? Isolate the radicals. In this case, I would combine like terms because it's a little messy. So 3x plus x, 4x. Put that way down there. And then we have this 4 and a 5 plus 9. Leave the other side alone. And then copy down what's left. What's left?
2 square root of 3.
Yeah, this mess. 2 square root of 3x plus 4 square root of x plus 5, and that's added on to 4x plus 9. Okay. Now we can isolate the radicals in this case. Subtract 9, subtract 4x. Subtract 9, subtract 4x. Okay. Do you think I'll put this one on the test?
You
No. And the only reason is this one's just messy and it just takes a very long time. You're going to get to a nice answer, but it just takes too long and it really doesn't test your abilities that much. It just tests your extra abilities, I guess you would call it. So on the left-hand side, you have 2 square roots of 3x plus 4, and then a square root of x plus 5, multiplied together still. The other side is negative 2, negative 6x. Have I made any mistakes? I hope not.
So are those two being multiplied or they just together?
These are multiplied. There's just no dot in here. I mean, you could write it the square root of 3x plus 4x plus 5. You know, using that property of square root of a times square root of b is square root of ab. There's no difference. Okay, what can I do to both sides?
Square.
I would divide by 2, make the numbers a little bit smaller.
If you don't divide by 2, then you square it, you square the 2 and the
Yeah.
bracket.
That would become 4.
Okay.
And then eventually you'd have to divide it across anyway, so you might as well just do it again. Even if it creates fractions, sometimes you just might want to do it. And then just be careful of the fractions on the other side. So left-hand side is the square root of 3x plus 4, square root of x plus 5, equals negative 1 minus 3x. Remember to distribute that division by 2. Okay, now what can I do to both sides?
Square them.
Square them. So square both sides. I'm surprised no one said something yet. The answer is no solution because this side is
Negative.
negative. But it's really not because x can be anything. So that's why we're going to keep on going and see what happens. What happens to both of the square roots on this side? They go away because it's multiplied together, and you can write it as a single square root. So this becomes 3x plus 4 times the quantity x plus 5 is equal to, now let's see if we can square this in our heads.
1 plus
Negative 1 times negative 1,
1.
1. Negative 1 times negative 3, 3x, and we're going to get 2 of them, so that becomes 6x. And then negative 3x times negative 3x, it's a positive 9x squared. First, outer, inner, last. Or you could write it twice and FOIL it out. It's not a big deal. What do I have to do to the other side? FOIL it out. So I'm going to do it quickly. 3x times x is 3x squared. 3x times 5 is 15x. 4 times x is 4x. 15x plus 4x is 19x. 4 times 5 is 20, and this is equal to 1 plus 6x plus 9x squared. Whew. Which way should I shift things? Left to right or right to left? Yes, it does. For a small reason, it does matter which way you go. Left to right, why?
Or
Because the numbers are, I'm going to take the 3x squared out of the 9x squared.
But why would you want to go that direction? There's a real big reason. To keep the x squared
positive.
positive. You really want to keep x squared positive so it works out rather nicely with factoring. You don't want to factor with a negative sitting out front. So I'm going to make this thing left to right, but I'm going to write it backwards. So 9x squared minus 3x squared is 6x squared. 6x minus 19x, negative 13x. Did I do that the right way? Yeah, because it's this side to this side. 1 minus 20, negative 19, is equal to 0. Oh, that's not pretty. Took the left-hand side and subtracted it away from the right-hand side. So 9x squared minus 3x squared, 6x minus 19x, and 1 minus 20. All right, I have a problem. This is 6x squared minus 13x minus 19 is equal to 0. That's horrid. That's horrid. 19 doesn't factor, by the way. It's only 1 and 19. So I'm going to do a little trick. I'm going to factor 6 into 2 and 3 and see if this works. This is one of those neat tricks when the numbers get a little bit too big. And mix and match. So 2 times 19, 3 times 1. That's not going to be enough, right? And even if I mix it the other way. So 2 and 3 aren't going to work. How about 6 and 1? 1 times 19, and 6 times 1? 6. And 19 minus 6? 19 minus 6. It's 13. So we don't have to multiply 6 times 19 and go through the whole list of factors. It's going to be 6 and 19. So we're going to break it apart into 6x squared, 6x, 19x, and negative 19. You can go through. Oh, you
They ain't gonna be
the quick way sometimes with big numbers is just to try factoring the numbers into pieces. The most common would have been 2 and 3, but 3 times 19 minus 2 or 2 times 19 minus 3 isn't going to do me. So I separated it into 6 and 1, and if I do 6 times 1 and 19 times 1, I get 6 and 19, and they subtract up to 13, and it works. All right, what kind of 6, what kind of 19? Positive 6, negative 19, and then you know GCF, 6x left behind is x plus 1, and negative 19 out of the left-hand side left behind is x plus 1, and this is still equal to 0. Ah, it's horrible, isn't it?
This
Ooh,
problem been going on for an hour.
it has not, because the class is only an
I
hour.
forgot.
You're exaggerating.
I'm not playing.
Another edit.
It's gonna take up half of the test.
I would never put this on a test, but it will be on your homework, because you have plenty of time to do homework.
Oh,
So, set both factors equal to 0, and you get x equals
negative 1,
-1, and x equals
19.6.
19.6. Uh-oh.
It doesn't work.
Which one?
The fraction.
You sure?
I don't know.
Just because you don't like it? Now, I would check -1 first, because negative, you never know. So you plug it in here. 3 times -1. -3 plus 4. So this one will give us 1. -1 plus 5 is 4. Square root of 4 is?
2.
And 1 plus 2 is, let's see here. -2 times -1 is 2. 2 plus 7 is? Square root of 9 is? 3. So that one works. That's kind of cool. So -1 works. 19.6 does not work. Read the following.